And we are now recording. So for A1,
I think we have introduced ourselves like what they said.
what was that?
We have to introduce ourselves first.
Yeah. So my name is Adam Buell.
Hi, my name is Aldel Badrani.
All right, and then we are gonna get started on the limiting reagents. This is group 2.
Okay, so Adam is gonna start with the first part. I'm gonna do the second part. Okay, go ahead.
So for A1, we have CaCl2, and our volume that we find is going to be 3.5 milliliters. And then we end up getting the moles. So then once we do the calculations, we end up getting 0.00114 moles. And then after multiplying that by the molar mass, we get 0.1262 grams of the substance. And then when we move down to Na2CO3, we end up getting 1.50 milliliters for our volume. And then when we plug that in, we end up getting 0.0098 or 48 moles. And then once we multiply that by the molar mass, we are left with 0.05167 grams of Na2CO3. And then down to A2, we get the same volume as A1. So we already know that it's going to be the same amount of grams as A1 for that one, which is going to come out to 0.1202 grams. And then down to the next one, Na2CO3, we get a volume of 3.45 milliliters. And then once we put that through the formula to get our moles, we are left with 0.00112 moles of Na2CO3. And then we multiply that by the molar mass and get 0.118 grams. And then lastly for A3, we have our volume of 3.5 milliliters, which is the same volume as A1 and A2. So after we convert that to moles and multiply by the molar mass, we get the same moles of 12.62, or same grams of 0.1262 grams. And then finally, we have Na2CO3 for A3, and we have 7.05 milliliters. And then we put that through the formula, and we get 0.00229 moles. Multiply that by the molar mass, and we are left with 0.2428 grams. And then that is the end of our calculations for that section.
And for the calculation for the table 2, we start with the trial A1. So we have to first to know which one has less number of moles. In this case, we have Na2CO3. It has less molar number of moles. So yeah, so we chose this one. So after that, we are gonna multiply by the molar mass of the CaCO2, which is 100.08, and we get 0.0400. This is the theoretical yield, and to get the actual yield is just need to use the formula, which is the mass of the filter paper with the participate minus the mass of the filter of the paper. And in this case, we get 0.0395. The percent is going to be the actual on the which is 0.0395 over 0.0400 multiplied by 100, and for the first one we get 98.67%. For the next one, also we did exactly the same process. and we have the moles, which is 0.0011, which is the smaller one, and we're gonna multiply it by 100.08, and we get the result 0.1122. And the actual we did also the same thing. We get the result is 0.0993. The percentage also the same thing. Divided, multiplied by 100, we get 88.50%. The last one also we chose the lowest number, which is 0.0011. We're gonna do the same thing, multiply it by 108.08, and we get 0.1188. The actual is the same thing, gonna 0.9823 minus 0.8769. We get the result 0.1054. The percentage, the same thing, we're gonna divide it and multiply by 100, and we get 88.72. So we're done with the second part, and this is the result. Right here, we have the volume total for the A1, A2, A3, and also for the CaCl2, and also the volume for NaCO3, the same thing here. And we have all the results. So right here for the limiting region, so formula, so this one, because it has the less number of moles, we chose Na2CO3. For this one, for the other one, it should be CaCl2 because it has more number of moles. This is going to apply for the A1, A2, A3. Okay.
All right, and then I'm going to do number one, and you're going to do number two then?
Yes.
Okay. So yeah, when we go down to number one right here, the first question it asks is which ions are going to be present in the supernatant, and we predicted that CaCl2 would be our excess. So the ions that would be present would be calcium 2+ and then 2 chlorine ions. And then the next question is what would happen if we added more CaCl2, and we predict that nothing will happen because it would just be adding more of the same ions to the solution. And then the next question is what would happen if we added the Na2CO3, and then we would predict that well, first the Na ions wouldn't do anything, they would just be spectator ions, but then the CO3 would form with the excess calcium ions, and the precipitate CaCO3 will be formed.
Okay, and for the number two, if the calcium chloride is the limiting reagent, so in this case, the ion is going to be NaCl and CO3. So what would happen if we add CaCl2? So CaCO3 will be formed. And what for the C, what would happen if we add Na2CO3? No reaction because it's the same one.
All right, I think that concludes.
Right.
Yeah, I think that concludes our discussion here. I think that's everything. What about you, Ali? Is anything to add?
No, everything is, we did everything, so that's it.
All right, cool. All right, and that's going to conclude our recording.